What is the difference between MREL's VOD recorders and the OZM VOD 815? Thank you for your question. The OZM VOD 815 is a point-to-point time recorder and will display the average velocity between discrete points located in the explosives column. It relies solely on the accuracy of the measured distance between the two or more points and the speed and accuracy of the timer. This method is also called the start-stop timer method or the discontinuous method for determining explosives VOD. Point-to-point systems such as the OZM VOD 815 are generally only used on explosive samples, not in blast holes. They can work very well for determining the average VOD between two or more points in an explosives sample. However, the accuracy of the VOD result is extremely dependent on the perfect distance placement and orientation of the tips of the fiber optic sensors in the explosives by the operator. If the sensors are not placed at the precise distance apart, as selected in the OZM VOD 815 operations menu, or are placed at different angles or depths into the sample, the VOD readings cannot and will not be accurate. This makes this recorder very dependent on the accurate measurement of location and placement of the fiber optic sensors, even under controlled conditions, such as in samples of explosives. It can be done for explosive samples, there's no doubt. In contrast, MREL's continuous VOD recorders use VOD probe rods in samples of explosives. VOD probe rods do not require placement accuracy or measurements. Where the OZM VOD 815 can record up to 8 data points in a meter-long sample of explosives, the MREL VOD recorders can record a minimum of 200 data points per meter and up to 2,000 data points per meter of explosive. This allows the change in VOD along the explosive sample to be recorded easily. For use in mining or quarrying blast holes, the OZM VOD 815 requires running from 2 to 8 optical cables to the blast hole being tested. The ends of the optical cables, as mentioned earlier, must be placed at carefully measured positions within the explosives column in the blast hole. This is so that the distances between the optical cable ends is known exactly. Obviously, requiring multiple fiber optic cables and then positioning the tips of them at exact positions inside the blast hole explosives column is subject to error. Even if you could place them precisely in the blast holes before loading with explosives, imagine what happens to those positions when loading the explosives into the hole. In contrast, MREL's continuous VOD recorders use one length of VOD probe cable in explosives in blast holes. VOD probe cable does not require placement accuracy or measurements. MREL's continuous VOD recorders do not suffer from the inconvenience of running long lengths of multiple signal cables per blast hole, nor do they suffer from the very likely inaccuracy in using the point-to-point method. The MREL VOD recorders can record a minimum of 200 data points per meter and up to 2,000 data points per meter of explosive in blast holes. This allows the change in VOD along the explosives column to be recorded easily.